All right. Wow, full room. I'm just going to jump right in. About 15 years ago, my stepmother, and we'll call her Frances for the sake of this conversation, became ill. She had aches through her whole body. She had weakness. She had difficulty standing. And by the time they got her to the hospital, she had paralysis in her arms and legs. And it was a terrifying experience for her and obviously for us as well. Turns out she had something called Guillain-Barré syndrome. Has anybody heard of this before? I'm just curious. Oh, lots of people. Good. Well, not good. Hopefully you haven't had firsthand experience with it. It's an autoimmune disorder, and it's a really interesting one. It's triggered by some kind of external factor, which is fairly common with autoimmune disorders. But what's interesting about this one is that the antibodies will directly attack what's called the myelin sheath that wraps around the axon, that long section in nerve cells. And it essentially eats away at it, such that the signals become very diffuse. And so you can imagine these symptoms of pain and weakness and paralysis are all quite logical when you understand what's going on. The good news is that it's treatable, either through plasmapheresis, where they filter your blood outside your body, or antibody therapy, and that was successful. The latter was successful for Frances. What was interesting also was her reaction to this condition. She became much more disciplined about her health. She started eating right, exercising more. She started doing Qigong and Tai Chi to improve her health, and she was committed to having this kind of event never happen to her again. And what this event really underscores for me is how amazing the human body is, and how something as simple as the act of breathing or interacting with the world is actually a pretty miraculous thing. And it's actually an act of bravery to a certain extent. There are so many forces in the world, so many allergens and bacterial infections and various things that can cause problems for us. And so you might be wondering, why the hell are we talking about this at a microservices talk? But just as breathing is a miraculous act of bravery, so is taking traffic in your microservice architecture. You might have traffic spikes, you might have a DDoS attack, you might introduce changes into your own environment that can take the entire service down and prevent your customers from accessing it. And so this is why we're here today. We're going to talk about microservice architectures which have huge benefits, but also talk about the challenges and the solutions that Netflix has discovered over the last 7 years, wrestling with a lot of these kinds of failures and conditions. So I'm going to do a little bit of an introduction. I'll introduce myself. And I'm going to spend a little bit of time level setting on microservice basics, so we're all using the same vocabulary as we go through this. And then we'll spend the majority of our time talking about the challenges and solutions that Netflix has encountered. And then we'll spend a little bit of time talking about the relationship between organization and architecture and how that's relevant to this discussion. So by way of introduction, hello, I'm Josh Evans. I started at Netflix, had a career before this, but this is the most relevant part. In 1999, I joined Netflix about a month before the subscription DVD service launched. I was in the e-commerce space as an engineer and then a manager, and got to see that transition from an e-commerce perspective in terms of how we integrated streaming into the existing DVD business. 2009, I moved over right into the heart of streaming, managing a team that's today called Playback Services. This is the team that does DRM and manifest delivery, recording telemetry coming back from devices. I also managed this team during a time when we were going international, getting onto every possible device in the world, and just this side project of moving from data center to cloud. So it's actually quite an interesting and exciting time. For the last 3 years, I've been managing a team called Operations Engineering, where we focus on operational excellence. Engineering velocity, monitoring and alerting, so think about things like delivery, chaos engineering, a whole wide variety of functions to help Netflix engineers be successful operating their own services in the cloud. So you'll see that there's an end date there. I actually left Netflix about a month ago, and today I'm actually thinking a lot about Arianna Huffington. Catching up on my sleep for the first time in quite some time. Taking some time off, spending time with my family, trying to figure out what this work-life balance thing looks like. Actually, this will be mostly life balance, which will be great. Big shift from what I was doing before. Netflix, as you know, is the leader in subscription internet TV service. It produces or licenses Hollywood, independent, and local content. has a growing slate of pretty amazing originals, and at this point is at about 86 million members globally and growing quite rapidly. Netflix is in about 190 countries today and has localized in tens of languages. That's user interface, subs, and dubs. Thousands of device platforms. And all of this is running on microservices on AWS. So let's dig in and let's talk about microservices from the abstract sense. And I'd like to start by talking about what microservices are not. I'm going to go back to 2000, my early days at Netflix, when we were a web-based business where people put DVDs in their queue and had them shipped out and returned and all of that. So we had a pretty simple infrastructure. This was in a data center, hardware-based load balancer, actually very expensive hardware that we used as our Linux hosts, running a fairly standard configuration of an Apache reverse proxy and Tomcat, and this one application that we called Java Web. It's kind of everything that was in Java that our customers needed to access. Now, this was connected directly to an Oracle database using JDBC, which was then interconnect with other Oracle databases using database links. The first problem with this architecture was that the code base for Java Web was monolithic, in the sense that everybody was contributing to one code base that got deployed on a weekly or bi-weekly basis. And the problem with that was when a change was introduced that caused a problem, it was difficult to diagnose. We probably spent well over a week troubleshooting a slow-moving memory leak. It took about a day to happen. We tried pulling out pieces of code and running it again to see what would happen. And because so many changes were rolling into that one application, this took an extended period of time. The database was also monolithic in even a more severe sense. It was one piece of hardware running one big Oracle database that we called the store database. And when this went down, everything went down. And every year, as we started to get into the holiday peak, we were scrambling to find bigger and bigger hardware so that we could vertically scale this application. Probably one of the most painful pieces from the engineering perspective, other than the outages that might have happened, was the lack of agility that we had because everything was so deeply interconnected. We had direct calls into the database. We had many applications directly referencing table schemas. And I can remember trying to add a column to a table was a big cross-functional project for us. So this is a great example of how not to build services today, although this was the common pattern back in the late 90s and early 2000s. So what is a microservice? Does anybody want to volunteer their understanding or definition of what a microservice is? I'm sort of curious what I'll get here. Somebody, some brave soul. There we go. What's a microservice?
Context-bound and data ownership.
Say it again.
Context-bound and data ownership.
Context-bound and data ownership. I like that. I'm going to give you the Martin Fowler definition. This is a good place to start. That's definitely a key piece. I'm going to read this to you so you don't have to. Microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process and commuting with a lightweight mechanisms, often an HTTP resource API. So I think we all know this. It's a somewhat abstract definition. It's very technically correct, but it doesn't really give you enough of the flavor, I think, of what it means to build microservices. When I think about it, I think of it as this extreme reaction to that experience that I had back in 2000 with monolithic applications. Separation of concerns being probably one of the most critical things that it encourages. Modularity, the ability to encapsulate your data structures behind something so that you don't have to deal with all of this coordination. Scalability, they tend to lend themselves to horizontal scaling if you approach it correctly. And workload partitioning, because it's a distributed system, you can take your work and break it out into smaller components, which make it more manageable. And then, of course, none of this really works well, from my perspective, unless you're running it in a virtualized and elastic environment. It is much, much harder to manage microservices if you're not doing it in this kind of environment. You need to be able to automate your operations as much as possible, and on-demand provisioning is a huge, huge benefit that I wouldn't want to give up if I were building this. Going back to that theme of the human body and biology, you can think of microservices also as organs in an organ system, and these systems that then come together to form the overall organism. So let's take a look at the Netflix architecture a little bit and see how that maps. There's a proxy layer that's behind the ELB called Zool that does dynamic routing. There's a tier that was our legacy tier called NCCP that supported our earlier devices plus fundamental playback capabilities. And there's our Netflix API, which is our API gateway that today is really core to our modern architecture, calling out into all of the other services to fulfill requests for customers. This aggregate set that we've just walked through, we consider our edge service. There's a few auxiliary services as well, like DRM, that support this, that are also part of the edge. And then this soup on the right-hand side is a combination of middle tier and platform services that enable the service to function overall. To give you a sense of what these organs look like, these entities, here are a few examples. We have an A/B testing infrastructure, and there's an A/B service that returns back values if you want to know what tests a customer should be in. We have a subscriber service that is called from almost everything to find out information about our customers, a recommendation system that provides the information necessary to build the lists of movies that get presented to each customer as a unique experience. And then, of course, there's platform services that perform the more fundamental capabilities. Routing to get so microservices can find each other, dynamic configuration, cryptographic operations, and then, of course, there's the persistence layers as well. These are the kinds of objects that live in this ecosystem. Now, I also want to underscore that microservices are an abstraction. We tend to think of them very simplistically as, here's my nice horizontally scaled microservice, and people are going to call me, which is great if it's that simple, but it's almost never that simple. At some point, you need data. Your service is going to need to pull on data for a variety of reasons. It might be subscriber information, it might be recommendations, but that data is typically stored in your persistence layer. And then for convenience, and this is really a Netflix approach that I think many others have embraced, but definitely specific to Netflix as well, is to start providing client libraries, and this were mostly Java-based, so client libraries for doing those basic data access types of operations. Now, at some point, as you scale, you're probably going to need to front this with a cache because the service plus the database may not perform well enough. And so you're going to have a cache client as well. And then now you need to start thinking about orchestration. So I'm going to hit the cache first. Then if that fails, I need to go to the service, which is going to call the database. It'll return a response back. And then, of course, you want to make sure you backfill the cache so that it's hot the next time you call it, which might just be a few milliseconds later. Now, this client library is going to be embedded within the applications that want to consume your microservice. And so it's important to realize from their perspective, this entire set of technologies, this whole complex configuration is your microservice. It's not this very simple stateless thing, which is nice from sort of a pure perspective, but it actually has these sort of complex structures to them. So that's the level set on